Welcome everyone. In this video, let us solve this question. So we have k raised to power 6 is equal to minus 64. So what to solve for the value of k? To do this, solution. First, we have k raised to power 6 is equal to minus 64. Move this to this side. We have k raised to power 6, then plus 64 is equal to 0. With this done, 6 can be written as, we have k, 6 can be written as power of 2 times 3, 2 times 3 equal to 6, then plus 64 can be written as 4 raised to power 3. This is then equal to 0. With this, following the law of indices, that if you have a raised to power m times n, this can be written as, in bracket, a raised to power m power of n. So writing this in this format, have it that in brackets k raised to power 2 power of 3 then plus 4 raised to power 3 is equal to 0. At this junction, what you have is sum of 2 cube, okay? And if you have a raised to power 3 plus b raised to power 3, this equals a plus b multiplied by a square plus b square minus a times b. Okay, now in this case, a is equal to k square, while b is equal to 4. So applying the value of a as k square and b as 4 into this, what we have is, in brackets, a is now k square, then plus b is 4, all multiplied by a squared, that is a is k square. So you have in brackets a as k square, then the squared, then plus b is 4, so 4 squared, then minus a is k squared multiplied by b is 4. It's all equal to 0. So it's all equal to 0. From here, k squared plus 4 is equal to 0. So k squared plus 4 is equal to 0. Or this here also is equal to 0. So you have k raised to power 2 times 2 is 4. Then plus 4 squared is 16. Then minus k squared times 4 is 4k squared. It's all equal to 0. So from here, we have it that k squared is equal to plus 4 moves here, it becomes minus 4. Or from here, we are arranging this becomes k to the power 4, then minus 4k squared, then plus 16 is equal to 0. To then solve for k here, right, to square root both sides. So k squared is equal to plus or minus square root of minus 4. So square cancel square root, k stands alone. K is then equal to plus or minus root of minus 4 can be written as root of minus 1 times 4. So we have it that k is then equal to plus or minus root minus 1 is I, and root of 4 is 2. So 2 times I is 2I. So with this, we've gotten the first value of k as plus or minus 2I. So then from here, let's then get the other values of k. We have it that k raised to the power 4, then minus 4k squared plus 16 is equal to 0. From here, this can be written as k raised to the power 2 all power of 2, then minus 4k squared plus 16 is equal to 0. What you have right here is a quadratic equation. So to solve it, we introduce the quadratic formula, which is given by k squared is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So here, the value of a is 1. Okay, so 1. The value of b is minus 4. So minus 4. And the value of c here is the constant, which is plus 16. So 16. So applying this, the value of a, b, and c into the equation, let's then solve for the value of k squared. K squared is then equal to minus b is minus 4, in bracket minus 4, plus or minus square root of b is minus 4, so in bracket minus 4 all squared, then minus 4 times a is 1, so 1 times c is 16, 16 all over 2a, 2 times a is 1, right? So k squared is then equal to minus times minus 4 is plus 4, plus or minus square root of minus 4 squared is 16, then minus 4 times 1 is minus 4 times, you have 16 here, all over 2 times 1 is 2. So k squared is then equal to 4 plus or minus, now we have it that 16 is a common factor here, right? So factorize out root 16. So root 16 from here, you have times root minus 4 plus 1 remaining, then all over 2. K squared is then equal to 4 plus or minus square root of 16 is 4 times root minus 4 plus 1 is minus 3, then all over 2. With this, k squared is then equal to 2 we divide 4, you have 2, plus or minus 2 we divide 4, you have 2 times root minus 3 is root minus 3. But then, we are asked to solve for the value of k, not k squared. To then solve for the value of k, what we will do is that we have k squared is then equal to 2 can be written as 3 minus 1, then plus or minus 2 times root minus 3 can be written as root minus 1 times root 3. Okay, so k squared is then equal to 3 minus 1 is 3 minus 1, then plus or minus 2 times root minus 1 is I, then times root 3. With this, note that I squared is equal to minus 1, and also 3 can be written as, in brackets, root 3 all squared. Square will cancel square root, 3 stands alone, so 3 can still be equal to 3 from here. So with this, k squared is then equal to, in place of 3, we'll bring in root 3 all squared. So in brackets, root 3 all squared, then minus 1 is I squared, so plus I squared, then plus or minus, you have 2I, right? Then times root 3. Okay, with this, if we rearrange this, we're going to have k squared is equal to root 3 all squared, then plus or minus 2I root 3, then plus I squared. And this is in the form of a squared plus 2ab plus b squared, and this expression is for a plus b all squared. Okay, so where a in this place is root 3, and b is equal to I, so I. Now in place of this, we'll put in a as root 3 and b as I. So then k squared is then equal to this right here. So in brackets, a is root 3, then plus b is I, then all squared. So to then solve for k, square root both sides, k all squared is equal to plus or minus root, right, in brackets, root of 3 plus I all squared. So with this, square cancel square root, k is then equal to plus or minus square cancel square root, you have it as root 3, then plus I. And this is the other value of k apart from this. So k is equal to plus or minus 2I as the first value of k, and this is the second value of k. So I hope you all enjoyed the video. Don't forget to like the video, subscribe to this channel, and also you can feel free to ask your question in the comment section. Okay, see you in the next video.